Hello everyone, this is the video for section 15.1. We're going to be starting chapter 15, which is on statistics. Is not going to be a lot of really in-depth statistics, so if you've had a statistics class in the past, you might sort of be cringing a little bit, thinking that's going to get really intense. It's not. It's going to be a very K6 perspective on statistics, but still a lot of ideas and a lot of terms, a lot of approaches that you still need to know. It's a very definition heavy and a very explanation heavy chapter. Maybe not quite as much computation as in other chapters, but don't let that fool you. Just because there's a lot more words and a lot fewer numbers in some instances doesn't mean that it's going to be any harder or any easier. So let's get started. So a couple definitions. Data, and data is both in a singular form and in a plural form. So you would a singular, data or data point, and then sometimes we'll hear data referred to as a set in the plural. And so in both cases, it's the same word. So there's no data and datae or datas or whatever. It's just data, singular and plural. And a data point is pretty much any piece of information that we are concerned about. So we'll talk about a little bit later in the chapter why we want to be studying something and then kind of putting together the design of what we're going to be doing. But whatever it is, we're going to be collecting these pieces of information, which we're generically going to refer to just as the data that we have. Now, the data gets split into two different categories. So you can see there's numerical data and there's categorical data. The numerical data is going to be things that we record that are numbers. And so you can see there in the example, really common data points would be like height or weight or age. Now, categorical data are things that we put into categories. And so you can see the examples there on the slide of things that we could use for categories. This might be a little bit confusing because you might be thinking, well, once you go through and you collect all that categorical data, aren't you going to count how many you have in each category? And then when you count that up, doesn't it become numerical? To a certain extent, that's true, but that doesn't make it numerical data. So if you think about how you would record the data, so if you were to go and ask the people in our class, what is your height or what is your age? You would not make columns on your piece of paper with different heights or ages because you might get something that wouldn't fit into that category. You might also get somebody that gives you something that's not going to be in that column. If you were to ask my daughter how old she is, she'd say 8.5. And you're probably not going to have a column for 8.5. And then, for much younger children, you're going to get things that are down to ages or down to months or maybe even to weeks. And so it's almost impossible to anticipate all those possible categories. So you're just going to write the number as you get it. So when you're writing down numbers, you're probably doing numerical data. Now, if you were to ask, do you live on campus or off campus? You're going to draw a line down that page and you're going to put on campus and off campus. And even though somebody may say, well, it's complicated because I live here, but I do that, and for the most part, you're going to put a mark in one column or another, and that becomes categorical. Yes, in the end, you're probably going to count what's in that category, and you are going to get a number from it, but think about how you get recorded and think about the answer that you get. Somebody's going to tell you, I live on campus. That's not a number. Somebody's going to tell you, I am 35 years old. That's a number. So it can help you kind of think about which is which, thinking about how you would record the data as you get it. We have two different types of studies that we can do. The first one here is called an observational study. In an observational study, it's exactly what it sounds like. You're studying by just observing. You're not trying to alter anything. You're not trying to change anything. You're not trying to influence anything. You are completely third person from what's happening. You are outside of that system and just sort of watching what's going on. If you go stand at an overpass going over, say, 35W, and you start marking down what color cars drive by, you're not influencing anything. Hopefully, the cars driving are not going to change color because they see you standing there watching what's going on. So you are outside of what's going on. Sort of the opposite of this would be an experiment. Now, an experiment is anything where we are intentionally changing something about what's going on. And so you might think of something pretty high level, like any sort of drug study. So right now, um, there's a lot of drug studies that are in the news. So there are experiments that take place to make sure that the vaccine is being tested does in fact do what it needs to do. That's clearly an experiment because that vaccine is being administered by somebody. Now, there might be people in the experiment who aren't getting the vaccine, and we'll talk about that a little bit more later on. So because there are people who are not being influenced or changed or altered in some sort of way, doesn't make this any less of an experiment. If there's anything at all in that study that's being influenced by the person doing the study, this becomes an experiment. If you got 100 people and 99 aren't doing anything, but you're influencing that one person, this becomes an experiment. Probably not a very good experiment if you got 1 versus 99 there, but it's still an experiment. We're not going to talk an awful lot about this distinction. A lot of what we're going to be doing are going to be observational studies in this K6 level, but it is important that we understand the difference between them because as students go on, they'll be seeing some things that are experiments and they may be seeing them in your class. Two really important definitions that we need to know are the distinction between a population and a sample. A population is everybody that we're concerned about within a study. It's everybody. It's everybody. Now, the sample is a smaller part within that population. So, suppose that we're talking about all the people in the United States. That's our population for this study. So we may ask people that are only students at Augsburg, or maybe only people within Minnesota, or maybe only the people that you live with. That forms a sample of that population. Now, if we want to do a study about everyone in the entire world, now all the people in the United States are no longer the population. The population is now everybody on the planet, and so all the people in the United States would now be a sample. So would the people at Augsburg, so would the people in our class, so would the people in Minnesota, the people in your family or whatever. So those are all still smaller parts of that. So just because something sounds really big, like everyone in the United States, instinctively you might want to think that's a population because that's a really big group of people, but you need to ask, well, what is the study asking about? What is the study trying to measure? What is it that we're interested in? What are we looking at? And if it's larger than everyone in the United States, it could be just North America, it could be just this hemisphere, um, then we know that we're dealing with a sample instead of a population. We also have the idea of a representative sample. And a representative sample is one that reflects the proportions of the population. So if we wanted to know what percentage of people in the United States have snow tires on their car, if we go look around Minnesota in January, we're going to find a lot more people. It's not reasonable to assert that as many people in Texas or Florida or Arizona are going to have snow tires on their cars as in Minnesota. So selecting Minnesota as that sample for the population of the United States would be very unrepresentative. We've taken a sample that does not really reflect the whole population. As you might imagine, sometimes people take unrepresentative samples intentionally and maliciously because they're trying to prove some sort of point. They're trying to extrapolate out from that unrepresentative sample that the population thinks, believes, does something that they want to try to convince you that the population says, thinks, or believes, and this is not the case. So sometimes when you ask, well, how was this sample taken, or how was the sample constructed, and you find out that the sample wasn't really constructed very well, then you know that the result of that study can be called into question. A really common, really popular way that this occurs are things that are done by telephone poles. So if you think about it, who has access to a telephone? I mean, sometimes people believe that everybody has access to a telephone. That's certainly not the case. And so people who don't have access to a telephone or have access to a permanent address can be left out of studies. So there's that piece of it that comes up more frequently than we probably would like to believe. You also have anytime that a telephone study is done, say in connection to a news program or any sort of program that has an opinionated tilt to it. Well, the people who are watching that show probably agree with that viewpoint, so they're probably going to call in and express the viewpoint that's being perpetuated by that program. So that's self-selected. I mean, anybody could call, but only people who probably follow that program and agree with that viewpoint are going to be the ones who call. So that's unrepresentative as well. Sometimes you get an unrepresentative sample where it's accidental, or maybe it's an accidentally bad design. So it's not always malicious, but we have a duty to ask, well, how was this sample taken? And then then from there find out whether or not we believe it's representative or not. Now, one way to get a representative sample is to do a completely random sample. So we're going to use some sort of process to randomly select people. And you want it to be done in a way where everybody has an equal chance of being selected. We can get into the weeds with what do we mean by random a little bit, which we're not going to really do in this class. So there are some ways in which something can seem random, but it really isn't. We're not going to worry about that too much. We're just going to sort of hand wave this definition of random a little bit and just say, okay, well, if it feels random for the most part, we're just going to assume that it's random. More than anything, we're going to work against something that seems overly intentional, that we intentionally select a certain group of people or certainly exclude a certain group of people, whatever that may be. So if we want to know the opinion of something within our elementary school, if we just ask the people in our class, say a fifth grade class, that's a very unrepresentative sample because we've left out everybody else. And, we've left out the kindergartners and the first graders and everybody else. So that's not random. Even if we randomly select within our class, it's still within a group that was very specifically and very narrowly selected. Now, this leads us to a really big question, and that's how big does a sample need to be? Again, this is a really complex question, but I'll say to this that how the sample is constructed is far more important than how big it is. So again, if we wanted to know something about everyone on the planet, and I were somehow able to ask everyone just in the United States, that's a really big sample, but it's a very poorly constructed sample. So I could ask a tenth as many people as the population of the United States and spread it around the globe a lot better. And even though I'm asking far fewer people, I'm getting a much better sample. So how the sample is constructed, far more important than the size of the sample. Getting more bad data typically doesn't help anything. And there's kind of a funny saying that statisticians have where they say garbage in, garbage out. The more bad data I get, just the more bad results I'm going to get. So the size is not nearly as important as the way that it's constructed. So let's look at an example that actually uses a little bit of mathematics here. So suppose a factory has just made 1,000 light bulbs, and we take 10 of them, and one of them doesn't work. So we've taken a random sample. We've just randomly selected 10 of the 1,000 light bulbs that were just made in this factory, and we found that one of those light bulbs that we selected doesn't work. So now we can make a prediction on this. How many of those 1,000 might we now predict would not work? So what we found is that 10% of the sample didn't work. So we might, from that, do a proportion, and let's say we've got so we want to know some amount that doesn't work out of 1,000. Well, that should be proportional to the one that we found out of 10. So this is my statement about the population. This is all of the light bulbs that we've made today. I don't know why I made that a plural, just population singular. And then this is what I know from the sample. So for my sample, I had 10%. So within my population, my guess would be also 10%. I would have this proportion, and my speculation would be, my guess would be, my prediction or conjecture, hypothesis would be that 100 light bulbs within all of those 1,000 don't work. Now, how confident can we be in that prediction? Well, more confident than if we didn't do anything, but we know there's some error in that because I might grab another 10 light bulbs and maybe all of them work. I might grab another 10 light bulbs and none of them work. So I don't know that everything's going to follow this 10% rule that I've gotten from this first sample. The only way I can be 100% confident that I know how many light bulbs don't work is if I test the population, if I just test everything. But that may not be a reasonable thing to do. I mean, I don't have time to, be popping in 1,000 light bulbs. So I want to be able to take a sample, but I know that that sample is going to have some sort of error. So this third question, what can I do to make the prediction better, is that I could either do a better job of constructing my sample. Well, I've already done a random sample, so I really can't really improve on that. Or I can make it a little bit bigger, keeping in mind that there's an upper limit to how much time I want to put into that. Some of you might be thinking, I thought you just said on the previous slide the size of the sample doesn't matter. The size of the sample doesn't matter if the selection process is flawed. In this case, we're doing it in a random way, so getting more will be good up to a point. We have to weigh that against how much time and effort and energy we want to put into that. So in this case, the size of the sample is going to matter a little bit more. But again, if the selection process was flawed or faulty, then more bad data isn't going to help anything out. So this last bit, I'm just going to warn you that this is going to get pretty serious and pretty real. So if any part of this starts to bother you, may want to skip ahead a little bit. But this is really an important part, and it's something that might come up in your classroom, and it may be something that you've experienced in your own personal life. And that's the question of, why would you not want to do a random sample? There are cases where we're not going to do a random sample, and there's a very scientific and reasonable way. I mentioned earlier about drug studies. And a lot of times in drug studies, people will be assigned to groups, whether they're going to get that treatment or whether they're not going to get that treatment. And you don't want to do that randomly. If somebody is really close to recovering, you would not want to take a chance with their recovery by giving them something that's untested and might make them worse. If they're on a path to getting better, you're going to want to keep them on that path. Now, the other side of this is probably pretty obvious. A lot of times, people who do get these experimental drugs are people who are pretty advanced in their illness, and they would be asked and they would consent and they might agree. And so we've lost a little bit of randomness there because they're selecting to be in the study. It would be really unethical to tell somebody, we're going to give you this experimental treatment when they're pretty close to the end, and then give them something different. There's a lot of ethics that are sort of wrapped into that, as you might imagine. And so in that case, you may have somebody that feels like, we've tried everything and nothing has worked. This may be my one chance to see if this is going to do anything any better, and we're going to cross our fingers and hope and pray that it does. And so in that case, somebody is selecting to be in that treatment group, and that's not random. So this does come up where we get people that are selected intentionally into one group or another for a very specific, very intentional, but also very humane and ethical reason. So this may have come up, like I said, in your own history within you or your family or somebody care about. You may have heard of this thing before, but also keep in mind that if you're doing this with a class, you may have a student who points out somebody that they know or somebody that they care about or somebody in their family was part of this. And so just be aware, this is a topic that is not uncommon to come up. All right, so as our checkpoint question, we got 80% of the members of the baseball team at our local high school say their favorite sports team is the Minnesota Twins. So do you think it's fair then to say that 80% of all students at that school would say the Twins are their favorite sports team? Or do you think it's true that 80% of all high school students in general would say the Twins are their favorite sports team? So why or why not? So the why or why not is a whole lot more important than the yes or the no. So what about what we've talked about? Think about the terminology that we've used. Try to use the terminology that we've used in your explanation. Why or why not do you think that would be the case? If you have any questions, as always, bring them to class, and we'll do the best job we can at getting them answered. All right, thanks.